Yes, so hello everyone. It's 4 p.m. Monday afternoon. Welcome everyone. It's great to have you here. It's our fourth webinar that we are doing together with AWS. You see two people here in this webinar. That's Simone Pomato. He is a solution architect at AWS, and he will do the majority of the webinar today. And it's myself, Marco Kundig, a managing partner at Copit. So we are a small group today, but as always, these webinars are recorded for the benefits for those people that cannot join right now in the live session. But here we are live, and we are doing this fourth webinar. So Simona, next slide, please. So what we look at today is, in the webinar 4, is cloud-native applications with Lambda and DynamoDB. I have asked Simone to prepare a webinar, a presentation, and a demonstration to show you how we can build cloud-native applications today on a very modern framework and at very low cost to run these applications. Before we jump in, I would like to give you a short introduction of who we are and what we do, and then Simone will run through the presentation. Simone, next slide, please. So the agenda that we are looking at, we run roughly for 45 minutes. Simone has quite a few slides that he wants to show, and he also has a small demonstration. So we'll probably need the full 45 minutes. And the agenda that we have is the introduction, as we do right now. Then Simone will go through what AWS Lambda is, what the benefits are, how you use it, and all those things. Then he will do a quick primer on DynamoDB, why DynamoDB is there and how you can use it to create cloud-native applications. And at the very end, there is even a demonstration where Simone shows you how we can build today cloud-native applications together with AWS Lambda and DynamoDB. Next slide, please. So you are hosted today from Copit AG. Copit AG is a born in the cloud company. We really focus on AWS. AWS is our main partner that we work with. We also do containers and Kubernetes. So we have been involved in quite a few container projects, not only Kubernetes, but also Fargate or Docker projects. So we can run containers everywhere. But our preferred platform, obviously, is to run it on AWS with either Kubernetes or Fargate. We have the experience in both of those. And for those that have an on-premise environment, still have on-premise, we are also a Puppet partner. We do have quite a few people working on Puppet, so we can help you there as well to automate your infrastructure with Puppet Enterprise and Puppet Open Source. We can do both. And obviously, as we are a cloud, born in the cloud company, we also do cloud consulting and a small pet project that our CEO is very much focused on is on IoT. So we have built some solutions in the IoT space where we can help as well. In total, we are 13 employees. We are based in Zurich and St. Gallen. The headquarters is in St. Gallen area, but most people are actually working out of Zurich. So that's we focus entirely on Switzerland. So these days, most of the projects are anyway remote. To myself, I don't present today much, so I don't go into all the details, but I have been working with AWS for probably 6-7 years now. I got 8 AWS certifications, including DevOps Pro and SA Pro, also the Kubernetes admin. So quite a few certifications that I have achieved over the past couple of years, and I've been in IT for almost 25 years. Good, so that's actually all from my side. I think I can hand over to Simone so that he can run through his presentation to show you how we build today cloud-native applications. Simone, the stage is yours.
Okay, thank you, Marco, for the introduction. And yeah, we can move into the presentation. And as Marco mentioned, we will start with AWS Lambda. But first, just a few words about myself. So my name is Simone, and I'm a solution architect based in the Zurich office for AWS. I've been in the company for more than 4 years now, and in my role, I do help customers choosing the right services and being successful with AWS services. Yeah, we'll start with an introduction to AWS Lambda. We will then move to DynamoDB, and then we will have a demo. Starting with AWS Lambda. So what is AWS Lambda? So Lambda is a function as a service that allows you to run code without provisioning or managing any servers. So with Lambda, you just pay for what you use, and what you use here is only the execution time of your functions. And we will see later what it means. And in Lambda, basically, you write your own code, you put your code in Lambda, and Lambda will do the rest for you. So it will do load balancing across multiple and parallel executions. It will auto-scale. It will handle failures. It will manage the security and isolation, the operating system behind the scenes, and everything. So you just have to write your own code, write your own function, upload it to Lambda, and then you will get an endpoint to invoke it. And Lambda is part of our serverless services. And serverless is a new concept, is a relatively new concept in computing, in particular in cloud computing, that is based on basically on four points, on 4 tenets that you see here. So the first one is that you don't have infrastructure to manage or to provision, so no servers. The second is that it scales automatically, so you don't have to create auto-scaling or those things. The third is that you pay for the value. And so the value here is only the execution time of the function. So you don't pay for any server, you just pay for the milliseconds that your function is running. And finally, serverless means high availability and security. So you have your functions that are already highly available, that already use multiple availability zones within the region. And if we look at the operating model of AWS, going from left to right, we have less to more, let's say, automation, which is done by AWS. And if we look at the compute side, we start from the left, where on-premise you have virtual machines. And if you want AWS to help you with more management, you go to EC2 instances. Those are basically virtual machines in the cloud where AWS manages everything from the hypervisor to the network layer and to the physical infrastructure. You can move a bit more to the right, where we have services like Elastic Beanstalk, where we provide already pre-configured environments, for example, for PHP, and so on, for other types of applications. And then moving to the right, we have services like Fargate, where we provide serverless compute capacity for your containers. And then last, we have AWS Lambda, where you just write your code and we do the rest. And if we look at the operational responsibility within some AWS services, we have the EC2 instances, which are the infrastructure as a service, where AWS is responsible for the physical hardware, the networking, and the facilities. So we start from the hypervisor downwards, that's AWS responsibility. On the other side, the customer is still responsible for managing and configuring everything from the host operating system upwards. So every application code, OS updates, and so on, it's still a responsibility of the customer. Then we have services like ECS and EKS, which are our managed container orchestrators. And in this case, AWS is responsible for managing the control plane of the orchestrator. So if you think about a Kubernetes deployment, you need to manage Kubernetes, and you need to manage the containers on top of it. With ECS or EKS, with EKS in particular, we manage Kubernetes for you, and you just have to run the virtual machines and then the containers on top of it. If if you move one step forward, we have AWS Fargate. And this is a serverless container compute capacity that is available for your containers. And if you run containers on ECS or EKS, by default, you run them on top of virtual machines, on top of EC2 instances. But you also have the possibility to run them on Fargate. And in this case, you don't have to launch and maintain instances. You just launch and maintain containers. You specify the CPU and memory, and we take care of provisioning that CPU and memory for you. So you don't have to care about scaling virtual machines. But if you want to move a step forward again, you have AWS Lambda, which is completely serverless function. And here you just write the function, you just write the code. You don't even have to maintain a container image. You don't have to update a container image. You simply write the code, and we provide the runtime and the rest that you need, so that you just provide the code, and the code will work for you automatically. And looking at how Lambda works, so AWS Lambda is a function. So in Lambda, you can define a custom code, a custom function in any of the programming languages that you see here, but also in any other custom language that you want by providing custom runtime. And then you can have an event source that triggers the function. And this event source can be either a change in data state, for example, a new record in a database, can be an invocation, direct invocation of the endpoint, or it can be a change in resource states. For example, when you launch a new server, you can trigger a Lambda function to execute some code. And then the Lambda function will execute its code, and during that execution, it can invoke third-party services or AWS services, for example, a database or an endpoint. And looking at how a Lambda function works, so we have here a very basic example, and every Lambda function has a handler. And handler is basically a function within your Lambda, and this handler is what gets executed during Lambda invocation. So when you invoke the Lambda endpoint, this handler gets executed. This gets triggered, basically. And in the event parameter, you can pass any parameter that you want. And then you have the context object where you also have some additional information, such as the request ID. And then you can write your own custom code. And in this custom code, you can do anything. And then you can return something. And this is how very easily a Lambda function works. And you just write the code, and we do the rest. So you write the code, you get an endpoint, and it will work for you. You don't have any server to manage, any container, anything, just the code. And the easiest way, let's say the most basic way to invoke a Lambda function is through its own API. So you create your function, and you get an endpoint. And with the API, you can invoke the function in synchronous or in an asynchronous way, and you can pass any event to the function. You can invoke the API directly, or we do provide also SDKs for you to invoke it with your own favorite programming language, for example, if you want to integrate it in your own existing environment. And there are 3 execution models for Lambda. So the first is the synchronous execution model, and here basically you basically send a synchronous push request to Lambda. So you send an invocation to Lambda. Lambda will run, and it will respond with the results. And this is let's say the most basic way to execute Lambda, but you can also execute it in a synchronous way through an event. So you have AWS services that can generate events, for example, SNS, which is a pub sub endpoint, or S3, which is our object storage service. And those services can generate events. For example, when you upload a new file to S3, it can generate an event. And you can subscribe this Lambda function to the events, and when an event happens, Lambda will be executed in a synchronous way. So you can respond to any event in the AWS platform. And then a third way is through streams. So you can have services like DynamoDB, which is a database, a key value database that we provide, or Kinesis, which is basically a stream service. And whenever there are changes in the data here, Lambda can capture those, can pull those changes, and then execute custom code. And there's also a concept in Lambda which is called dead ladder queue. So when you invoke your Lambda function in an asynchronous way, the function is retried 3 times. And if the function fails after those 3 times, the payload can be sent to a dead ladder queue, which is a queue where you can have all the payloads that failed. And this way you can debug errors, why errors occur and everything. So you are sure that you never lose any request. And talking about permissions in Lambda, so you have 2 layers of permissions. Lambda permissions are very granular because with function policies, you can define who can trigger a Lambda function. For example, you can say that a specific S3 bucket can trigger the Lambda function, but another bucket cannot. And then you have the execution role, which is basically the permission that the Lambda have. For example, your Lambda function could have permission to look into one DynamoDB table, for example, the users table, but not into another table, which may be the orders table, for example. So you can go very granular with that. And also pricing is very granular, and here it's very important because with virtual machines, the unit of price is the uptime of the virtual machine. So if the virtual machine is up and running for 1 hour, you pay for 1 hour. Even if the instance is stale for 50 minutes and only executing, only consuming CPU for 10 minutes. On the other side, with Lambda, you just pay for the function execution time. So if you have a function that runs for 100 milliseconds, you just pay for those 100 milliseconds. So you don't have to pay if your code is not running. And this is very, very appealing. There are multiple architectures that are available for Lambda, and here are some examples. So this is not all the possible architectures. You can do basically everything with Lambda, but here you have some common use cases. So one use case is that you use S3 as an object storage service to store your files. And whenever a file is written, a Lambda can be invoked automatically to do some code. You can have an SNS endpoint, which is a pub sub endpoint in the cloud. And whenever data comes, Lambda is invoked automatically if you configure it. And then you have SQS queues. Those are basically queues that are fully managed by AWS, and you can push messages to the queues, and Lambda can pull messages from the queue, can execute some code, and when it's done with processing, it will remove the message from the queue. It will acknowledge the execution, and then it will pull the next message. Another set of architectures are here. For example, if you use Amazon Kinesis data stream, which is a streaming service, you can have Lambda automatically pull streams, and it can pull streams in parallel. So Lambda will always scale automatically. So if you have 1 or 10 or hundreds of concurrent executions, Lambda scales automatically for you. And another use case is with chatbots. So we have a service that is called Lex, where you can create your own chatbots with natural language processing and intents recognition with the same technology that powers Alexa. And you can use Lambda functions to add some logic. So whenever a user makes a question to Lex, Lex will understand the intent, and then it will invoke a Lambda function for that intent. And another way to execute Lambda functions is with scheduled executions. So you can have fully managed cron jobs in AWS, and Lambda that get executed with those cron jobs. And there are a number of customers that are using Lambda at scale. For example, Thomson Reuters is using Lambda with 4,000 requests per second. Expedia is using that with more than 1 billion executions per month, and so on. And it can scale very well to many, many requests. And this is how Lambda works. So we will see a bit more in the demo, but now we switch to DynamoDB. And to understand how DynamoDB works, I quickly want to have a look at the data amount that systems are processing recently. So the data that system process increased more and more over time, and this makes it a bit challenging for relational databases, because relational databases, we know, they don't scale very well. And this is why very recently we started introducing NoSQL databases. And NoSQL databases are different types of databases that don't use SQL, but that use, for example, key value, document storing, column-oriented databases, or graph databases. And all of those databases are optimized for scaling and optimized for performance at any scale. And to understand the difference between SQL and NoSQL, we can have a look at this slide where we see the architecture of a SQL dataset. And this is, as you see, this has a lot of relations, and data here are normalized. On the other side, in a NoSQL database, you don't have relations. All the documents, all the records are not related one to the other, and the data here is denormalized. And the advantage of a NoSQL database is exactly in the fact that data is denormalized, because denormalized data takes more space to store, but when you need to retrieve the normalized data, you simply use a key value approach. So you don't have to scan, you don't have to make costly joins, and this is very, very efficient. And in fact, due to the relational nature of SQL databases, scaling is very slow. And in fact, you can only scale up in most cases a SQL traditional database. And the reason is that you have all those relations, and you cannot really scale out those relations, the data, to multiple instances, because you have to maintain those relations. On the other side, with a NoSQL database, you can easily add more instances, more partitions, whenever you need more compute capacity or more memory. And the technical challenges of scaling relational databases are that, so the first one is that you need to scale to a larger instance always. So it's very difficult to shard your database. So most of the times scale up the instance size, but larger instances do not always exist. So at some time you may need to shard your database, and this is very painful to do. We have a service for relational databases, which is called RDS. RDS helps minimize those pain points, but it doesn't resolve the issue of SQL databases completely. And on the other side, NoSQL databases are very easy to scale, because as we saw, there are no relation between the data, and the partitioning scheme is very plain. It's very simple, and you basically have a partition key where all the data are partitioned based on that key. And this makes it easy to break up those partition keys, to break up your partitions based on partition keys, so that you can scale in a horizontal way very easily. And so if we look at NoSQL and the advantages, so the main advantage is that you can scale very quickly at an affordable price. So you don't have relations in the data, so you can scale very quickly. You don't have to worry about those relations, and this makes it very efficient to scale, and so the price remains constant. And also the performance remains constant. With NoSQL databases, you can have 1,000 records or 1 billion records, and if you designed your database well, you will always have the same performance, which is not the case with SQL databases. And then you have a flexible schema. For example, in DynamoDB, you can store any kind of data, for example, JSON data or strings or integers. And you don't have to define the schema in advance because any document is independent from the other. You can put any data in any document with no fixed schema. But if we look at the, let's say, disadvantages of NoSQL databases, so the first one is that if you need complex joins in your queries, such as the ones that you do in with SQL databases, then NoSQL databases may not be a good fit. So you, in many cases, you can rewrite for NoSQL databases by changing the data structure, but in some edge cases, you still need SQL databases. And then SQL databases, they can be, let's say, a good option when you have small databases and you just need to execute flexible and ad hoc queries. In that case, it's very flexible with the SQL databases. And yeah, if we look at our NoSQL databases, one of them is DynamoDB. This is, let's say, the oldest one of the ones available. And it is fully managed. It offers consistent, fast performance at any scale. It's highly available and durable. It's secure. It will integrate with Lambda, and we will see it in our demo. And it is cost effective. And we will dive deeper in those points in the following slides. But before we do that, so how does DynamoDB works? So in DynamoDB, you have a database. You don't have servers. You simply have tables. So you enter in DynamoDB, and from there you can create your own tables. And to create a table, you don't need to create servers. You simply create a table, and then on that table, you can perform millions of requests per second, and you can store trillions of items. And the database will scale automatically. You simply have your own table, and you simply write and read from that table. And the service will manage the scaling for you, will manage the repartitioning for you. You simply write and read, and you can do it at any scale. As you see here, we have an example where we go from 0 to 300 millions of requests per minute. And as you see, the performance gets stable, remains stable. So you have the latency here, and the latency stays between 6 and 3 milliseconds per item at any scale. So at any scale, you keep a single-digit millisecond latency. So this is one of the very important points of DynamoDB. And you don't have to manage connections of any kind. You just have the endpoint, and you simply write and read from that endpoint via REST API. And when you write something on DynamoDB, we make it highly available and durable for you. So you simply write it to the endpoint, and we put the data in one availability zone in at least one data center, and then we replicate it to at least 3 availability zones, so at least 3 data centers. And this makes the data very available and very durable. You also have backup and restore features in DynamoDB, which is also fully managed. So you have on-demand backups that you can enable for long-term data. And then you also have the possibility to set point-in-time restore. And point-in-time restore allows you to recover your database at any point in time for the last 35 days. So you use point-in-time restore for the last 35 days, and then on-demand for the older data. And all the backup and restore is fully managed by us. Again, you don't have to write any code. You don't have to run any database, any server. It's all managed by AWS. Another point on DynamoDB is the security. So DynamoDB is fully integrated with identity and access management for authentication and access control. And you have a very fine-grained access control. So you can define who can do what. For example, who can write on a table, who can read from a table, and you can assign permissions in a very granular way, up to the item in the table, so up to the row in the table, or even the attribute. So even the column in the table. And you can at rest, and encryption in transit is always on because you invoke it with HTTPS. And the service will integrate with CloudWatch, where you can monitor the service for metrics, and with CloudTrail, so that you always have a trail of all the API invocations.
Simone, a question here?
Yeah, sure.
So the question is, I often deal with clients that have difficulties to get the technical users correct. So, for example, an API layer talking to the database layer and having a good authentication in place. You mentioned it before that you can use IAM here in place. So, can we use roles and all those things of AWS to talk to DynamoDB?
Mm-hmm. Did you ask about roles, right? Did I understand well?
Yes, correct. Yes.
Yeah, so actually identity and access management is where you define and you manage users, roles, and groups. And so the answer is yes. You can use, for example, roles to define who can invoke a specific query on a specific table, for example, and who cannot. And you can assign roles to a virtual machine or to a Lambda function, so that Lambda function has the role, has the permission to invoke the DynamoDB table.
Cool, and that means no more keys, no more securities that need to be solved. It's all bound to that role. Cool, excellent, thank you.
Exactly, yeah. Perfect. Yeah, and in terms of scaling, so you have 2 dimensions that can scale on DynamoDB. The first is the throughput, so the amount of queries that you can do in a specific amount of time. And the throughput can be defined on an on-demand manner. So if you choose the on-demand throughput, you don't have to scale the capacity. You just choose on-demand and you query, and that's it. On the other side, you can provision the capacity. It will cost you less for a capacity unit, but you need to scale the capacity up and down depending on the amount of queries that you do. And you have capacity auto-scaling, where you can set rules. For example, you can set that when you are querying more than 70% of the actual capacity, then you scale it up automatically. And when you scale the throughput, behind the scenes, we create partitions, we create new partitions, and this is totally transparent to you. So you just need to scale the throughput or to keep on demand, and we will do all the repartitioning behind the scenes. Another thing that you scale in DynamoDB is the size of the database, so the amount of data, the storage. And basically for the size, you don't have to worry about anything. Whenever you add the data, the storage increases, and whenever you delete an item, the storage decreases. So it will automatically adjust, and you just pay for what you use. And finally, we can have a look at how DynamoDB table works. So you have a table, you have items, so each row is called an item in DynamoDB. And then you have attributes, so you have A1, A2, A3, A4, and 5, and so on. And as you see, when you put an item in a table, you don't have to specify the same columns. For example, column A3 is here in item 1, but it's not here in item 3, where you have column A6. So you have a full flexibility in terms of columns that you store. And then you have a partition key. So you have to define an item that is always present in your table, and this is called the partition key. And this is mandatory, because when you want to retrieve the same item, you simply provide the key, the value of it, and you will get it with single-digit millisecond latency. So you don't have to scan all the table, you simply do a key value retrieve. You can also specify an optional sort key, and this allows you to perform queries with operators like the ones you see here, for example, smaller than or larger than. And then you can also define local secondary indexes, and it means that you keep the same partition key, but you project the data with a different sort key. And this allows you to retrieve the data with your sort key, but also with another key if you need to. So this allows more flexibility in the queries. And another option is to use global secondary indexes. And with global secondary indexes, you keep the same. So you can also change the partition key. So you have the same item, but you can project the same item with a different attribute as a partition key and with a different attribute as an optional sort key. And this allows you again to have more flexibility in querying the items. And that's it. So we have a lot of customers that are using DynamoDB, and those customers are using it in a very, let's say, a very intensive way. For example, here you can see some very large customers. One of those is Amazon, of course, Amazon.com, that uses it in its own e-commerce for displaying items on the pages, or Duolingo that uses it for its own application. And they all get these single-digit millisecond latency. And that's it. So it's time for demo. I will go to the demo of Lambda and Dynamo.
Simona, there is a question before we go into the demo from Rafael. So the question is, can the partition key be auto-generated, or does it have to be user-defined on every insert operation?
Yeah, you have to provide a partition key. So you can have for example, a process that will generate an incremental partition key if you want to use an incremental partition key. But usually what we recommend is that you define a partition key that has a meaning, so that you can easily retrieve the data with that partition key. So Marco maybe can help you with that later on if you go with DynamoDB, but the main point is that in SQL databases, you had that schema with incremental IDs. In DynamoDB, you can still use that. It's perfectly fine to use them, but you can go, for example, with another key which has a meaning and which makes your queries more useful than simply an incremental ID. But definitely, technically, you can do that. You would have to define, by the way, a process that increments automatically the ID or generate a UID, because DynamoDB doesn't generate the UID for you.
Yeah. Cool. Thank you. That's fine.
Perfect. Good. So if there are no other questions, I will go to the demo. And this is a demo of Lambda in DynamoDB. So the demo is here and is publicly available. And this is part of the architecture that you see here. And this architecture will create a service for basically doing for booking rides in a very similar way to Uber. So the service is very similar to Uber or other ride booking applications. And this is built fully with serverless services. We will do just the part of Lambda in DynamoDB here, but you can also do the rest, and it will create a fully serverless application. So for the Lambda and DynamoDB part, we will create a Lambda function that will invoke DynamoDB, and it will invoke DynamoDB to write on the database your booking. So you book a taxi, Lambda will receive your position, it will do the booking for you, and then it will save, it will persist the booking ID with the information on DynamoDB. So let's do it. We first need to create a DynamoDB table. We will create a table which is called rides and which has ride ID as a partition key. So I go to the console of AWS, I search for DynamoDB. I create table, I call it rides, and the partition key will be ride ID. It should be a string, and the rest is okay. So I create my table, and my table is created. So I wait for it to be ready, and I see that I get an ARN here, which is the identifier of the table that I can use to invoke it. Then the table is ready. Let's create an IAM role for Lambda function. I will create a role for Lambda. I go to IAM, and this role will give Lambda permissions to run the function, to invoke the table, sorry. I go on roles. I click on create role. I create a role for Lambda. I click on permissions. And here I can give Lambda the possibility to access that specific DynamoDB table only. In this case, we don't have a lot of time, so I will give Lambda full access to DynamoDB. But in production use cases, you should give access only to that specific table. So I go to next, click on review. I give it a name, Lambda role, right? And I create the role. So this is the role that Lambda will use to invoke the DynamoDB table, to access the DynamoDB table, and then I will create the Lambda function. So I go to Lambda, and I create a function called request unicorn. So the funny thing here is that you don't request a taxi, you request a unicorn. But yeah, let's do our function. So I go to Lambda. I create a function. I call it request unicorn 2 because I have already a function with the same name. The runtime should be Node.js. No, yeah, Node.js. So Node.js 6 is not there because it's not supported anymore. We can use the Node 10. And then I created a function. And from there, I will copy this code here as the code of my function. The code is not here anymore. Good. But I already created the function previously. So I can go to my functions here, and I have here my function request unicorn already created. Yeah, as you see, I created the function. I will add the code to my function. And this is the code that gets invoked when I invoke the function. So I have the handler here. The handler will basically make a request to DynamoDB. Yeah, and it will basically put a record on DynamoDB. The table here is called rights. And yes, when I invoke the function, it will basically put the data on DynamoDB. As you see here, there's a DynamoDB put SDK call, which in turn invokes the DynamoDB API and will put an item on the table. I can test it, so I click on test, and it will invoke my function. Now the function has been invoked. Here I should have the response. As you see, the response is 201. If I go to DynamoDB and I go on items, no, I think here, yeah, okay. Here you see that items has been written, and you see that I have a write ID, a request time, and you see that I can write any JSON in my data, and I can write any column. So very simply, you invoke the function, you can make calls, for example, to DynamoDB, and this all works automatically, and this can scale to millions executions in parallel, and there are no connections to manage, no servers to manage. This is all automated. Good. Yeah, I would say that's it for the moment. Maybe any questions or?
Fantastic, Simone. Thank you so much for showing us first a presentation and then a very quick, brief demonstration of how we can build a cloud-native application in a fully serverless way. So you basically have used serverless code and you have used a serverless database. So this will run at almost no cost. And if the business scales and needs millions of requests on the database or on the Lambda functions, your application will scale and still will be quite cheap to run this. So there is a question. So one of the questions that came in is, can you tell us an example where a customer can move from a traditional server database setup to use Lambda functions instead?
Mm-hmm. Yeah, we see a lot of use cases for Lambda and for DynamoDB as well, and we see many customers migrating. So there's not really one use case. There are customers doing analytics. There are customers doing web services. Sorry. There are customers doing any kind of API. There are customers doing also batch workloads with parallel executions. There are even customers hosting machine learning inference on Lambda. So let's say any kind of use case can run on Lambda. And as you saw, there are many advantages in Lambda. So you have very granular pricing, only for milliseconds your function run. You have no servers to manage, no container. You just write your code and this works. And you can be very fast with Lambda because you just write code and each team writes its own Lambda and it's all very microservices oriented. And so a lot of use cases can go on Lambda, and you get the advantages of Lambda. Yeah.
Yeah, cool. So, but what also can be said is that, for example, the traditional applications, for example, like WordPress is always a good example. WordPress is not optimized for Lambda, so you cannot take the WordPress code and put it on Lambda, and that won't work. Can you confirm that?
Yeah. Exactly. Yeah, WordPress is more a CMS for content service, for content serving. It's not optimized for Lambda. On the other side, if you have a website with APIs that you expose, then in that case, it's more optimized. It's more of a use case for Lambda. Yeah.
Yes, cool. And also PHP as an application language is I think is still not supported officially for AWS Lambda. So it's more the modern applications like Go and C++ and stuff like that that are more suited. And obviously, what also needs to be said is, if you don't have access to the code, like you don't have access for SAP or for whatever closed source, you can't put it on Lambda. So if you want to run it on Lambda, you need to bring the code, and it needs to be not compiled code. So else you cannot put it on Lambda. So no closed source. Or not saying, if you own the code, you can put it on Lambda, and it also should be optimized for Lambda usage, because Lambda is an event-driven platform. So if your software is written that it runs continuously on a VM or a container, then put it on a container or a VM. And if you want to put it on Lambda, you have to rewrite the code. Best is if you, so we see a lot of startups going the Lambda part because they anyway start from scratch. They can build a microservices event-driven architecture, and the Lambda is really perfect to choose for as an application execution engine. Cool. So any other questions from the audience? No, good. So we are anyway a bit over time. It's actually only 4 minutes, so it's amazing to see that Simone could run through all his slides, and the demonstration also went successfully. So thank you so much, Simone, for the presentation. And thank you very much for the audience for being part of here. And let's look at the next webinar that is coming up. It's actually the 5th webinar. It will run on the 16th of November, and it's very much container focused. So there we will look into Fargate, Docker, ECS, EKS, Kubernetes, all of these options that are available on AWS. And containers are certainly a very hot topic in Switzerland. So register, as always. You get a registration link. If you don't find it, it's cockpit.clickmeeting.com, and come there, register. And as always, these sessions are recorded. All the sessions that we have done so far, all the 4s are available in the archive. So have a look there. It is good to see what is also already stored there. So thanks again. Thanks, Simone. Thanks to the audience. Have a great evening. Talk soon. Goodbye.
Thank you. Bye-bye.
Bye.